All right, so this is an example of a question that you might get asking you to generate a slope field. So here's the given differential equation. So remember, differential equation has the derivative, or a differential dy over dx, equaling some function, either 2x or just y, or both x and y. So this is a differential equation. And in order to generate a slope field here, we're going to take the derivative, and we're going to basically mark out little slopes at each of these points to generate this sort of field. And the field is going to look like some of the stuff that we've done here before. See those graphs there. All right, so what we're going to do is we're going to understand that the derivative is defined by this right here. And where do we get the x and y from? Well, the x and y is basically the coordinates of each of these black dots that we're going to have to put this little tangent line on. So this point right here is 1, 1. Everyone see that? 1, 1. So in order to find out what the slope is going to look like there at 1, 1, we simply put in 1 for x and 1 for y. So that's going to be negative 2 over 1 is negative 2. Now what does that mean? Well, negative 2 is the derivative. That means that's the slope of the little tiny tangent line that we have to put there. And so again, negative 2, now it's going to be a little bit tough here, but you know, what's the slope of negative 2? Well, if you could envision, you know, rise over run, sort of, you know, negative 2. So you kind of want to draw it a little bit like this, okay? Now, I'm not going to be measuring this slope out, but you want to, you know, you want to do it as kind of close to reality as you can, okay? All right. So that's that, okay? Now we keep doing that for different points. So let's see, let's go to this one up here, okay? So that is 1, 2. And so if we have 1 up here, and we have a 2 in for y, at this point, that's going to be negative 2 over 2. That's going to be a negative 1. So what we need to do there is to draw a slope of negative 1. Okay, everyone see that? All right. I'll tell you what, I'm going to, let's do another one. Let's kind of pop over to, well, let's go down to this one over here. So this is 1, negative 1. So what happens here? Well, put a 1 there and a negative 1 down there. We get negative 2 or negative 1, and that's a positive 2 again. Or actually, not again. We haven't had a positive 2 yet. We had a negative 2. So this one looks like, you know, this kind of up 2 or 1, so it kind of looks like this, pretty steep. A reflection of this one, I guess. Okay, and again, you just keep doing that, and you put in the little lines there. So I tell you what, why don't you take a moment to finish? Okay, take a moment to finish and see what yours has looked like, and I'll just take a moment and finish up here as well. Okay, so go ahead and finish that. Okay, so as you're working on this, maybe you've come across the first pattern here. So if you look at these coordinates here, 0, 1, 0, 2, 0, negative 1, 0, negative 2, as long as you have a 0 in the numerator there, it doesn't matter what this number is, right? And so these are all going to be 0 slopes here in this vertical line. Wherever x is 0, the slope is going to be 0 there. Okay, you see that? Okay. And so I think the other ones should be like this, 2, 1. Well, that doesn't look a lot like that one. Sorry. Let me back that up a little bit. This is 2, and this is 1. And it should look like this. So I'm just kind of fast forwarding a little bit here. Okay. So your field should look like this. This would be negative 1, negative 2, positive 2, positive 1, and all these are zeros and so on. Does it look something like that? Okay, that's what it should look like. So again, just plug the points in, whatever your coordinate is. For example, we didn't do this one, but negative 1 and 1. That's a negative 1 goes there, and a positive 1 goes there. So that's negative 2 times negative 1. That's positive 2 over 1 would be positive 2. Okay, so that's how you get that slope. Any questions there? Okay, what does the graph look like? That's a good question. Now, we don't really know what the graph looks like, but this is a bit of a strange one, right? If you look, the graph is going to like come up something like this. Over here, okay, in this area, it should be a 0. So it's going to come like this, and it's going to go back down. Okay. Now, what about these points? What are those weren't on the original graph, but 1, 0. Okay. So what about 1, comma 0? What happens there? This is 1. This is 0. Ooh. So it's undefined. So we don't have a slope field. We don't have points there, or we don't have slopes there. So this really is basically like it could be a half of a circle sort of thing, right, or a semicircle there. Anything like that. Also could be, sort of like this too, I guess. So maybe a parabola or something like that. So depending on, kind of what we're having here. You wouldn't need to draw the functions, and you wouldn't need to speculate, but that's if you had to, that's what we had to do. So this one's just generate the slope field. Looks something like that.